Hi, everyone. Today we're going to talk about elasticity of demand. And this is a topic that you'll talk about in your econ classes if you haven't already. And basically, it relates to how sensitive the demand of a product is to the change in its price. So there are products that are elastic, which means when you change the price, the demand changes. For example, if I increase the price, people don't buy it. Or if I lower the price, people run out and buy it. So there's a sensitivity. People really respond to changes in price. And then there's something that would be inelastic, which would be an insensitivity to changes in price. Basically, things that are essential are typically these inelastic things. So even though you raise the price, people still have to buy it, or even if you lower the price, it doesn't create any major change in demand. So let me give you some examples of products along these lines. So examples of products that would be elastic. Okay, so elastic products. So these are products that you would wait maybe until the price drops in order to buy them. So things that come to mind would be like airline tickets, right? Don't we shop around for those things, kind of non-essentials. So things like furniture, right? Clothing. Again, there are exceptions and so on. But again, if you think of kind of the non-essentials, because we just really wait for those to come on sale in order to purchase them, or we wait till the price is where we want it to be. And then there are those things that are inelastic, where if the price changes, we still go purchase them. And the most obvious one, at this moment and over the years has been gasoline, right? Even though the price goes up, we still have to have it. So it's an essential item. And so, it's inelastic. They could keep raising the price and bring in more revenue, and we'd unfortunately still have to buy it. So things like that, I would say gas, like heating oil, essentials for kids like diapers, right? Lots of times milk is an essential item. If you have kids, soap, cigarettes if you're addicted, and so on. Okay, so these would be more of, the essential items. All right, heating oil, we don't rely too much on that in California, but people back east do. So these are some examples of those products. So we have a formula that will calculate the elasticity for us. And it's calculus based. So while you're in an econ class, you may do it with some algebra based techniques, which works, but it won't be as applicable to most problems. So for us, we can use these formulas. So if you have a demand function, so you have to have this demand function, right? That's essential. That'll be given to you. Then you can calculate elasticity by this nice little formula here. It's basically, and make sure you notice this negative right here, okay? So there's a negative right there. So it's the negative x times the derivative of the demand function divided by the demand function. And in this formula, just know that x represents price. Now, sometimes they use P for price, which tends to make more sense. So the formula can also be written this way, E of P. Again, watch the negative that's there. So it's price times a derivative of the demand function divided by the demand function, right? So you have to be given this demand function or given enough information to get the demand function. So once we have an elasticity function, we can identify the best price to maximize our revenue. Okay, or we can identify if at a certain price, a product is elastic or inelastic. Okay, so let me show you how that's going to work. Let's look at this first example. So we have this demand function. Suppose we have a demand function d of x for a certain product. And again, reminding you the price is x. All right, so I have this demand function here. It says find the elasticity function. All right, so that's just, applying a formula. Let me write the formula. So it's negative x times the derivative of the demand function divided by the demand function. Okay, so the elasticity formula would be just negative x. You don't put anything in for that. You're just keeping that variable there, multiplied by, now let's get the derivative of our demand function. So, okay, over here is our demand function. Let's get d prime of this. So the derivative of negative 1.5x is just negative 1.5. And then the derivative of 25 is 0. Okay, so this is a pretty easy derivative. All right, so the derivative of our demand function is negative 1.5. And then we put it over the demand function. So negative 1.5x plus 25. And then you just want to clean it up a little bit, right? Because we're going to be using this function. So on the top, two negatives make a positive. So let's write that as 1.5x over negative 1.5x plus 25. And that looks good enough. So that is our elasticity function here, okay? And I'll show you then, once we have that elasticity function, I can use it. So that's what the second part is. Calculate the elasticity of demand when the price is $12. So once I know the price, remember X represents our price, so that's $12. I can just plug that price into my elasticity function. So I'm going to find E of 12. And then I'm going to get a value. And then I'm going to use what we have up here. So let me go back up here. So the main thing is, if your elasticity comes out less than 1, which is a second case, then you would know that you have a product that's inelastic at that price, right? If the elasticity value comes out bigger than 1, it would be elastic at that price. So we just use these. And then if it comes out equal to 1, well, that's ideal. Equal to 1 is really the ideal situation, because that is when you're what we call unit elasticity, and you're going to be at a price that gives you the max revenue. Okay. So, all right, I'm going to plug 12 into my elasticity function. I'm going to have 1.5 times 12 divided by negative 1.5 times 12 plus 25. All right, type that in, give it a go. Let's see what we get. So I'm coming up with 18 on top, divided by, well, that comes out to 7 on the bottom. 18 over 7. Now that number 18 over 7, that is a number that is definitely bigger than 1. It's about 2 point something. So that's definitely greater than 1. So our rules up above said if it's greater than 1, then we know that our product is elastic at this price. So if you're setting your price at $12, your product is elastic at this price. And so elastic, what you should do here, since there'll be a sensitivity of demand to it, what we should do then is lower our price. So I'm going to say thus, lower the price. And what that does is it gets people coming to buy your product, and that will increase your revenue. So to increase the revenue. So that's my interpretation. So once I know whether it is elastic or inelastic, then I can tell you what to do with that price. You should try a price less than 12. How far less than 12? Well, I'm not going to calculate that right now, but I do know I should lower it a bit, and that will get more people to buy my product and increase my revenue. So that's the interpretation part of it, okay? All right, so that's what the problems are going to look like. All right, let's try another one. So they get more difficult when the demand function gets more complicated, right? So let's look at the second one here. All right, so same idea. You've got this business club. They collect data over the years from their raffles of these raffle tickets, and they come up with a demand function of this D of P, where P is our price, okay? And D of P is the quantity, the number of tickets they sell. Okay, find the elasticity of demand. So now they're using the letter P, so we're going to use the formula with the letter P in it. So negative P times the derivative of the demand function, divide it by the demand function. Okay, now we're not going to plug anything in for P, not yet. We're just finding the elasticity function right now. Okay, and watch out for the negative. You want to make sure you have that there. Okay, so we have negative P. Let's get the derivative of our demand function. Okay, let's bring that up here. Let's get d prime of P. Let's get our derivative. So the derivative of 36 is 0. The derivative of negative P squared will be negative 2P. All right, so that's our d prime. So negative P multiplied by negative 2P, all divided by 36 minus P squared. All right, let's just clean that up a little bit. So that's going to give me on the top, double negative makes a positive, 2P squared on the top, divided by 36 minus P squared. All right, that is my elasticity function. Okay. All right. Then it says evaluate E of 3 and E of 4. So now I'm just going to plug in 3 and plug in 4. So I'll give you a minute to do that, and then we'll compare our results and try to make a plan. Okay, so you plug in 3, you plug in 4, and you get these values. You get 2/3 and 8/5. Now 2/3 is less than 1. So at that price of $3, it's inelastic. So we'd want to increase our price. When you plugged in 4, you get a value bigger than 1, which tells you it's elastic, which says, oh, wait, you should decrease your price. So as far as what I can see here, I could conclude that I think our best price is going to be somewhere in between 3 and 4. Okay, so the best price must be between the $3 and the $4. I just have to figure out what it is, and that's actually the next question. Okay, so we know kind of where the best price for the raffle tickets is. Now, how do we find the actual best price? Well, the best price is when you have what's called unit elasticity, when your elasticity function equals 1. This is your best price. So to figure out what price will give us this unit elasticity, I'm just going to set the elasticity function equal to 1. So I'll take my 2P squared over 36 minus P squared, set it equal to 1, and then solve this for the price. And whatever price you get from this, that will be the best price. And what I know is it's going to be a price between 3 and 4, right? Because I've already kind of seen the information from part B. All right, so let's do a little solving here. Now, when you have this kind of a equation, I would suggest either like a cross multiply, right? You could think of the 1, think of this 1 here, if you like, as like 1 over 1, and think of this as a ratio and kind of cross multiply. How about that as a strategy here? I like that. So if I just do a little cross multiply, or if you like, multiply by the LCD, will result in the same thing. So if I multiply across 2P squared times 1, and then this times 1, here's what I get. I get 2P squared equals 36 minus P squared, right? And then I can solve. Let's add the P squared, bring it over here with this guy. So 2P squared and P squared will be 3P squared. And that's going to equal 36. Let's divide by 3. And that's going to give us a P squared equals a 12. And then I'm going to take a square root. Now I know it's a positive, so I don't need the negative answer. So P is going to equal the square root of 12. Now this is money, so I need an answer to 2 decimal places. So we'll type this in our calculator and we'll round it to 2 decimal places. So I'm going to say this, that the best price is, I'm going to type in square root of 12 and round it to 2 decimal places. And that gives you $3.46. That price is the price that gives you unit elasticity. That is going to get you the maximum revenue for your, what are these, raffle tickets? Okay. So that's how elasticity can be helpful. It can determine if prices are set correctly, and it can also find you the best price. So again, if they ask you for the best price, you're going to set this elasticity function equal to 1. Okay. All right, we've got one last one we're going to look at in this video. And this is the more challenging one because we have to come up with our own demand function. They did not give it to us. So this is more realistic, right? You have a car wash. You reduce the price of your basic wash as a promotion to test the market. And when you put the price at $11, your monthly sales has been $28,000. But when you drop the price to $8, your monthly sales, of course, goes up because more people come, $34,000. Assume the monthly sales are related to the price linearly. So meaning it's a line. So let me organize here. We're going to use X as our price because that's what we like to do for these demand functions. And then we'll call the Y value D of X, or the demand, right? In this case, it's not really quantity. In this case, it's a dollar amount, right? They say monthly sales. I'm assuming that's money, but actually it's not that clear, is it? All right, well, let me organize here. So they said when the price is 11, the demand was 28,000. And then they lowered the price to 8. And then it went up to 34,000. So what I want to do is write an equation of a line, and that will be my demand function. And then I'll do everything I just was doing previously. Okay. So anytime we have an equation of a line, we start with finding the slope. So start with your slope, right? Y minus Y over X minus X. And then we'll put it in a point slope formula. And then we'll get our equation of our line. So I'll give you a little time here. Get your slope, get your equation of your line. Okay, so if you went through all your steps, you found your slope of your line, which is negative 2,000. You plugged it into point slope or Y equals mx plus b, and you came up with your demand function. So I've highlighted that in yellow. So that's our demand function for this car wash, right? So finally, we had to do a little work on our own to get our demand function. All right, so now that we have that, let's go back to the problem. It says find the demand function where X is the price. Okay, I've got that answer. Let's just put that here, D of X, negative 2,000 X plus 50,000. And then of course it wants us to find our elasticity function, E of X. All right, well, now that I have my demand function, I can do that. So remember the formula, negative X times the derivative of your demand function divided by your demand function. Okay, so let's plug that in. So that's going to be negative X. Now the derivative of my demand function, D prime, is just negative 2,000. Divide that by negative 2,000 X plus 50,000. And you know, this is one I think I'm going to clean up and reduce a little bit. So the top I get 2,000 X. And on the bottom, I have this negative 2,000 X plus 50,000. Now I could divide, you know, just to kind of get my numbers smaller. So for my elasticity function, how about if I, you know, divide the top and the bottom, or basically what I'm doing is factoring out 1,000. Well, let's actually factor out 2,000 and make this a little cleaner. So think about in the denominator, if I were to factor out 2,000, I would have negative X plus, and then 2,000 goes into 50,000 for actually 25. So if I factor out a 2,000, again, you don't have to do this, but I just think it's going to make my number smaller and I'm going to like it better. So if I factor 2,000 out of the denominator, I can cancel with the 2,000 on top. So then here's a cleaner looking elasticity function. How about this? X over negative X plus 25. I like that better. Okay, so here's my elasticity function. Great. Then last question. What price is going to give you the max revenue? Okay, well, to do that, remember that's when we want to get unit elasticity. So I'm just going to take my elasticity function. So now I'm really happy that I did simplify it. and set it equal to 1. So x over negative x plus 25. Just set that equal to 1. Again, I'm going to think of it as like 1 over 1. So I can just do a little cross multiply and solve for x. And remember, x is the price, and then you'll have your answer. So solve this thing for x. So again, I'm going to do a little kind of cross multiply here. So I would end up with x equals negative x plus 25. Let's bring this up here. And then if I get all my x's on one side, so let's add this x and bring it over here. That's just 2x equals 25. And if you divide by 2, here's what I get, 12.5. Remember, this is money, so I want the decimal. And so as a money amount, that's $12.50. So I'm going to say this, the best price is $12.50 to maximize your revenue. So if you set the price at $12.50, you're going to get your best revenue, your max revenue. Okay. So again, we know how to max revenue in other ways, but elasticity is kind of nice because, I didn't even have to get a revenue equation to do it. I just had to get an elasticity function, right? Okay. Well, there is one more problem that has a more difficult demand function, and that's this last one here. So I'll make another video to show that. Again, the more challenge on that is just the algebra part of it. It's just all the algebra with the crazy fraction exponents. But hopefully these examples that we've done have given you enough experience to at least get the general idea, and you'll be able to cruise through those problems. Okay, until next time,